Welcome back to my channel, and we're continuing on with chapter 3. This is lesson 43. However, this is not a lesson that needs to be done to finish up the chapter. You can, if you've already done the other lessons, you can go on and take the test, and this is just an extra supplemental lesson. But it's good to know this stuff for the next chapter. So we're on activity manual page 50 if you have a book. If not, then you just follow along and do the activity with me. All right, so of course we're talking about measuring today. And I have many things here on my table that I want to show you. And they're all shaped differently, but they have all one thing in common, and that they all measure something. Up here on my podium, I have what we call a balance. Now, a balance is used to measure mass, or how much material is in a substance. And it's measured in grams, or sometimes kilograms. What it does is you put something on one side, and of course it's not balanced. And so they use weights here in the front, which is a known weight. This is, I think, up to 200 grams and then 10 grams. So they use a known weight to balance out the unknown weight. And when it's in the middle, it is balanced, and we know the mass of a substance. So some other tools that we're going to use today. Here we have what we call a graduated cylinder. And the reason why it's called a graduated cylinder is because each of the measurements along the side is equal distance. Okay, so graduated or equal distance. And cylinder is the shape. That's the scientific word for beaker. So I have a big one, and I have a kind of like its baby, this really tiny one. And we're going to use this later in our lesson. Something that you might be familiar with that's almost like a beaker. Maybe mom has something like this in her kitchen that she uses for cooking. And this is what we call a graduated container. That's different from the other one because of its shape. The first one, it was straight up and down. But this one, it's wide at the top and narrow at the bottom. But you still use it for the same kind of measuring. And with these two, you're going to measure volume, or the space it takes up in the middle of something, in the middle of the cup. So they come in all shapes and sizes, cups and milliliters and ounces. But it's a graduated container because of its shape. Graduated cylinder was the first one, graduated container. Another tool that I have that we're not going to use, but just to show you, this is called a barometer. And a barometer measures air pressure. Okay, kind of like this ball thing, kind of squeeze. It kind of reminds you of taking your blood pressure. Well, this actually measures the air pressure, a barometer. Another tool I have measures how much electricity is moving through an object. If I put the red and black wires on the opposite ends of a device, the negative and the positive, this needle will move, showing how many volts are running through it. That is called a voltmeter. All right. Another tool I have is this springy little thing, and we're going to use this next chapter. This is called a spring scale, and what it measures force, or how much force is being pulled on the scale, and it's measured in what we call newtons. One that you might be very familiar with, and I'll hold it up closer to the camera, right, is this little device. This is called a thermometer. And what does a thermometer measure? It measures temperature. And what is the unit of measurement? Degrees, either in Fahrenheit, which is what Americans use, or Celsius, which many other countries use Celsius, but also in the scientific field, we use Celsius, so to measure temperature. All right, I have some other tools here that are kind of similar. All right, so this one is very large. All right, this is what we call a meter stick, and it has 100 centimeters in it. It's almost the same size as a yardstick. Okay, and then we have something that's a little smaller, it's a ruler. Okay, so not only centimeters, but we have a smaller unit of measurement. It's called millimeters. All right, so meter, centimeter, millimeter. And then we have the really, really long one that can measure up to 20 meters. I have this called a tape measure. All right? And that tape measure is used for measuring long length or long distance. All right, so the ruler, the meter stick, the tape measure, that's all measuring length. Length, then centimeters, meters, millimeters. Two more. I have this funny shaped looking one here. This is called a protractor. Kind of looks like a rainbow. And what it measures is angles, okay? Like a 90-degree angle, a 45-degree angle. It measures angles. Last one, I don't have an example of, but I drew a picture on the board if you can see it. Now, when you're measuring your weight, you step on what we call a scale. And that scale, with the use of gravity that pulls on your body, you push on the scale and the number goes up, or it shows you your weight. Usually kilograms or in pounds, wherever you're located. Now, I do want to make a distinction between measuring your weight and measuring mass. Measuring mass is measuring how much substance is in that object, like how much matter is in it. Weight is the pull of gravity on the object, okay? Now I want to give you a little thing to think about. Think about your weight. How heavy are you? And I want you to imagine yourself going to the moon. All right, you're on the moon. Now, which is bigger, the moon or the earth? Well, if you said the earth, that's great. The moon is much smaller than the earth. And so if the mass is much smaller, it has less gravity. In fact, it has 6 times less gravity than on the earth. So if you're standing on the moon, are you going to weigh more or are you going to weigh less? Well, if you said less, that would be correct. Why? Because there's less gravity. There's less pull on your body. So let's give you a number. Let's say you're 42 kilograms. Okay? You're 42 kilograms, and you divide that by 6, you get 7 kilograms. So if you're on the earth, you weigh this, or whatever your weight is. But if you divide it by 6, whatever number you get up here, that's how much you would weigh on the moon. But if you think about it, your body didn't change. You didn't cut off your arm or your head or your leg to make your mass smaller. Your body stayed the same, but your weight changed because the gravity changed. All right, so those are some different things that we learned, different things that we can use to measure different things in science. So we're going to go to our lesson, page 50 in our activity manual. And what we're going to do is we're going to measure a stick of clay. We're going to get the grams or the mass of this lump of clay or Play-Doh, whatever you want to call it. All right. I'm going to get up a little closer so you can see the balance and what it does. Okay, so I'm going to put this in the center. All right, so it's not balanced, so we got to equal the balance. All right, so what we do is we start with this big weight and we click it over. And if you happen to get to play with one of these, that's a lot of fun. You keep clicking until the other side falls down. Now see, that's too heavy now, so we're going to click it one back. All right? Then we use this top one, this little tiny weight, just little grams. We move it, and we move it, and we move it, and we move it until it goes in the middle. Okay, so it's a little... You get a little closer so I can see the needle. Oh, it's a little too far. So I'm going to move that back just a little. All right, almost. That's pretty close. So what I'm going to do is I'm going to turn it so I can read the numbers. There's a number here in the window, and that's 70, and we add the top one is 72.3. 72.3. So if you write that in your activity manual, please. 72.3. And it already says the letter G for grams. 72.3 grams. Now let's go ahead and do the next one. You can put a check mark after that we finished that activity, that step 1. Now we're going to change the shape. All right, so here we're going to make a star. All right, not going to be a very good star, but a star nonetheless. All right, so we made a star. All right, let me ask you a question. Did I take away anything from the star? Did I take away any clay, or did I add anything to it? If you said no, that's correct. So let's see if the mass changes by changing the shape. What do you think will happen? Will it change its mass? All right, let's click it over. Oh, too heavy, so we got to click it back. All right, now we move the little one. And we move it over just enough to start balancing. That's really, really close. Okay, so I'm going to turn around and add the numbers together. All right. Yeah, it's just about the same. Okay. All right. Might be 1/10 of a gram off, but because maybe we changed the shape just a little bit, it distributed its weight just a little bit, but it's still approximately the same. So we could write 72.3 grams. Okay. And sometimes my scale works a little funny. Sometimes it's a little, like it has its own mind. So sometimes it doesn't work as correctly as it should. All right. Okay, so it's we can click that or put a check mark. Let's make another shape. Let's make a triangle. And you can try this at home if you have a scale, or I'm sorry, not a scale, a balance. All right, so we have a triangle shape. All right. Oh, unbalanced. So what we got to do, we have to balance it. So what do? We click, 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 click. Until when? Oh, too heavy. So what do? Click back. All right, and then we move the top one. That's pretty good. So let me turn around and check the numbers. We add them together. Yep, just about the same as before. So 72.3. All right. So let's answer the question. Did the mass of clay change? Yes or no? If you said no, that would be correct. Why? Because we didn't add or we didn't take away from the mass. We didn't add or take away from the mass. So let's go ahead. I apologize. I forgot to do the one last thing. Let's put this back up here. And what we're going to do is we're going to set it now to 50 grams. All right? So it's uneven. So we got to add pieces of clay. And we can add almost all of it because it's close to 50 grams. All right? So oh, it's too heavy, so we got to take away. Ooh, that's pretty close. You got to balance it. It's a little too heavy on this side. You got to take a little bit of it away. Let's see what happens. Nope, too much. Ooh, really close. There we go. So this mass now, oh, my little piece fell off. That's okay. Let's add it again. All right, yeah, pretty close. Oops. Right on the dot. All right, that's 50 grams of clay. All right, so we can check off number 5. All right, now let's go ahead and measure some volume. And so the first thing we're going to do is get our graduated cylinder. And we're going to measure all the way to the top, which is 500 milliliters. But we're not doing a liquid, we're doing a solid. All right? So these are, it says rice in your book, but I'm using aquarium rocks. This is what I had. So we pour gently until it rises all the way to the top. Gently, slowly. And we want to be accurate when we're measuring in science. Give it a good shake. It's a solid. Oh, right on the money. That's what 500 milliliters of rocks look like. So if you're doing this at home, you can practice with a graduated container, like a measuring cup. Now let's go ahead and go about to the middle, which is 200 milliliters. Okay? I'm going to try it again. I'm going to kind of get down low, see where it's pouring. If you think it's just right, give it a good shake so it's even. Oh, not there yet. Up to 200. Almost there. All right, that looks pretty good. That's about 200 milliliters of aquarium rocks. All right, you got to be accurate when we're being a scientist, okay? All right, now what we're going to do is measure liquid. And usually that's what you do in a graduated cylinder. You're going to measure liquid, the volume. So the first one we're going to do is 350, which here's the 300, and in the middle, that is 350. I'm going to turn it around so I can see. And we want to get down low so we can see right there. That's what 350 milliliters of water look like. All right, so we can check that off. Again, you can do this with a graduated container or a mixing cup or a measuring cup. Now 125, so here's 100. That's 150, so we're going to go about right in the middle. Okay? That's 150. It's a little too much. So pour out and let it settle. Just about right. That's about 125 milliliters of water. Okay. Well, I hope you had fun in this chapter learning about plants, and then this lesson learning about measuring. I'm curious to know if you did any of the experiments with the plants, the cutting, or trying to grow plants without a seed. And I want to know how your germination plant went if you happen to do that. I will see you next time. I hope you have a great day.